I just had a quick look at it, and it looks fantastic, but what the promo doesn't do is give any credit to the people that do all the work, which is Rupert and Thurston at the back. So my plan is that I might bring in a camera one week, and maybe someone here could volunteer to be a documentary crew, yeah, Luke or someone, and they could film Rupert and Thurston filming me. And then I could film you as a documentary crew, and that would be like, you know, the waterfall that goes down forever. That would be really cool. So we should just thank them. So can I just publicly say, well done, Thurston and Rupert, you're doing an awesome job. Well done. Who's actually looking at the videos? Who's finding them useful? Some. Is it worth us doing, is the question in my mind. Yes. Why? Because it's get them up faster. Yeah, we're working on that. That is our #1 problem at the moment. And the fact that I've been dubbed into like a Hong Kong action movie. So, like the fact I've been dubbed, I can't do it properly. But you watch the video, you'll see it. So yeah, we'll get them up faster. But why are they useful? Tell me why they're useful. Because they're enormously time-consuming to make. Why should we keep doing them? So you don't have to go to lectures. Well done. I mean, that's a good reason, isn't it? Or if you got sick or something, or you couldn't come in, or there's a public transport disaster, yes. A reference if you forget something, you go back. Has anyone gone back to look up stuff they didn't get? Yes. Was it useful? No, it wasn't useful. Was it useful?
We can actually concentrate on you now and take notes later.
You can concentrate now and take notes later. Hopefully that's sort of happening with the wiki anyway. Oh, you had a separate point. That's why you had your hand up. Hang on, someone that's gone back and looked at the notes. Has anyone gone back and looked at them and found them useful?
Yes.
Anyone at all? Yes. Why?
Because I missed something in the lecture and I just came back.
So you went to the lecture, something didn't make sense or you misheard a bit and you went, look, cool, excellent, okay. So look, if we've helped one person learn one thing, then that's, you know, putting a smile on my face. Well done, thank you. Now you had a question? Yeah.
So I can show my friends how cool my computing lecturer is.
So you can show your friends how cool your computing lecturer is, yeah. And perhaps we don't want them to know exactly how cool I am because that's a bit embarrassing. Yeah, no, look, the coolness in this course, I should say, we've got to reflect it back to you guys. The camera is only showing me, and that's because of privacy things. I didn't sort of want to show anyone's face because I wanted you all to be relaxed. But of course, this course is about you. And what makes the course different every year when we run it is that we have different students. I'm still here. Different students. We go in different directions. We get different feedback, different suggestions, different ideas. OK, yeah. OK. Any suggestions for improving the video? Just super quick, other than getting them up faster, which we know. Yes? Yes? Waving someone. Okay. That's excellent. So you have friends on the other side. That's excellent. I like to call this side the continually deprived of Mars bar side. And you know, I'm just waiting. There's one guy that's always sitting on this side, and one week he's going to sit on that side, and then bing, I'm going to bring the Mars bar in. and a big knife, and we'll chop it into all the pieces with it. Okay. Okay, shh. Are there people outside or people inside talking? If it's people inside, shh. If it's people outside, nothing we can do. Now, I had some good feedback from Luke, one of your class reps the other day, and the other class reps hopefully are all going to come and we're going to chat just quickly at the end of the lecture today. And that led me to go and contact some tutors and suss out a few things, and I did find that there's a group of people who are sort of struggling with the course and finding it quite hard, especially if the tutes are on a Tuesday, because on a Tuesday you have the least amount of time to do the labs. There's also a lot of people still trying to do the labs when they turn up to the lab. I think it sort of I haven't made it clear enough that that's not going to work, that you need to do the lab before you come to the lab. Who managed to do the lab before they came to the lab today? Or put an effort into it? Cool, that's good. All right, that's about 25%. But it should be everyone. If you just turn up to the lab and you think, oh, I'll start now, you probably won't get it finished.
That's cheating.
Oh, it's not cheating. No, it's a good cheating. It's cheating in a good... Yes, it's cheating. Yeah, we like cheating. Yeah. I mean, if you think about it, what's cheating? Cheating's like doing less work to achieve some outcome. So that's good cheating. I like that cheating. Yes. No, just stretching your arm. OK. So that made me think there are some people struggling a bit. So what I've done is I've rejigged the schedule slightly. I was going to release task 2 next week while I was away, and I was always unhappy about doing that. But I'm actually going to let everything slip back about 4 or 5 days. So task 2 is going to come out when I'm back, and then I'll push the extension date back a bit too. Does that make sense? The due date. I like to call it the extension date. Is there anyone that would not like me to push it back? Yes, why is that?
Because I feel it would probably be going too slowly.
Oh, okay, too slowly. That's okay. Well, I mean, I'll have to address that in other ways, other than going too slowly.
Because I'm bored.
You're bored and you want to do more interesting stuff. Let me give you a challenge. There's a room. In this room, there are 2 light switches. Oh, you know this one. Okay. What about the weighing coins one? Do you know the weighing coins one? No. Okay, here's the weighing coins one. You've got, you know, the famous balance scale that looks like that. And you've got some coins. Now, you live hundreds of years ago, and everything's done by weight. And you're the official counter for the king that has to count this stuff. And people bring in bags of rice, and you have to count them. This is for Marco Polo. You're loading Marco Polo's train up. Now, you can trust that everyone's filled the bag of rice up correctly. So there's no one that's trying to con you with a bag of rice. All bags of rice weigh exactly 1 kilogram. But they've got their bags of rice and they've tipped it into another container, and they bring this big container, and you need to know how much they've brought along. You need to quickly check it. You know it's going to be a whole number, okay? We're not going to move into floating point numbers. It's a whole number. They've brought a whole number of kilograms of rice, but you need to know how many they've bought. You've got a balance scale, and the only weights in the country, the official weights, are kilogram weights, and they're made out of gold. And you wonder, what's the smallest set of weights you could get to, say, work out all amounts between 1, oh, well, let's say 0, and 40. Now, you could call this out and spoil it for everyone, but I'd ask you not to do that. What's the smallest number of weights? Well, let's just practice this. What if we had to measure all, what if we just had, people could bring 1, 2, or 3? What weights would we need to actually determine? If we had a 1 kilogram and a 2 kilogram weight, then can you see we can measure 1, that's just a 1 kilogram. We can measure 2, that's using the 2 kilogram. And we can measure 3 by stacking them on top of each other. Does that make sense? So my question is, what's the smallest number you need to measure up to 40? And, no one call out. I want you to work it out. This is particularly for you, because I challenge you. I reckon the first answer you come up with will be wrong. And I also reckon probably the second answer you come up with might be wrong too. Okay, this is a very interesting puzzle. So I don't want anyone, don't want anyone to call out any answers. That's the challenge for people who are bored. Now, is there anyone who it's going to cause difficulty to if we adjust the assignment dates? That's what I need to know. Nothing to do with being bored. Yes?
Why don't we just release it on the day it's meant to be released instead of getting...
No. I don't like releasing it before we've done it. Then that helps the students who already know about the stuff that's in the assignment and freaks out all the new students. And it's the new students I'm worried about.
I'm just wondering what actual date you were going to release on?
Oh, the first lecture back after I get back. So it'll be on a Monday instead of the Friday before. But I just need to know, it's a very specific question. Put up your hand if putting the due date back will inconvenience you. Are you putting up your hand for that reason?
Yes, because I feel that it just cram things into me.
It's going to cram things around?
Yes, but...
How long do you think you will take to do the assignment?
Well, I don't know. I don't know what the assignment will be.
Okay. I guarantee if you are crammed at all, I will work out some way of giving you special treatment. Okay. Because he's not going to be crammed.
He's extending the due date as well, though.
Yeah, I'm moving everything. I'm moving everything back. 4 days. No, I'm not releasing it early. No. I know what you want.
You don't have to talk about it.
No, but I can't release it without talking about it. And I don't want to talk about it anymore. Oh, unless it's a problem.
What week will it be due then?
That many days after when it was originally due. Let's look on the schedule. You can't see. Okay. Let's see. Task. Task 2 is going to be released on the Wednesday and due on the Friday for experienced people. It will now be released on the following Monday. It was going to be due on the Friday, which was a holiday. It will now be due on, I don't know, that number of days more after that thing. Does that make sense to everyone? You'll get the same amount of time, but we're going to release it slightly later, because today my plan is, instead of racing through the stuff at the rate I'd planned, we're going to go through things a bit more slowly. And instead of having the extension lecture, being an extension lecture, It's cancelled, and I've asked Malcolm, the game designer, to come next week, and we're going to have a revision lecture for anyone who's having trouble with assembler. And we're going to go over assembly slowly for anyone who's having troubles. Does that make sense? So that's my plan for today. There is one hand waving. Yes?
So does that mean that task 2 will be released on 5 days after the Wednesday, so that'll be Thursday, Monday, and then due in on a Wednesday?
Task 2 will not be released on the Wednesday of one week. It'll be released on the Monday of the following week. And the number of days between those two dates will be added on to the due date. Yeah. Or more. Okay. Shh, but no less. All right, everyone. So here's my plan for today. Some people are having troubles with loops, so I thought I would go over loops in more detail, and I thought I would also release the solution to task 1. So maybe we should start with task 1. I wanted to talk about task 1 because you've all finished task 1 and handed it in and got it marked, and hopefully we'll get the marks back to you. We should get them early next week, and if we're lucky, we'll get some of them back late this week. For me, the most interesting thing about task 1, it's a fairly simple programming assignment in that it just involves a whole lot of ifs. So it's fiddly. There's not a lot of brain power going on there, unless you haven't programmed before, in which case there's lots of brain power because you're trying to work out how the heck to program. But once you can program, the complexity level of it isn't very high. It's just a couple of if statements. And if you've shot yourself in the foot and made your program more complicated than it needs to be, then you've got more if statements, and that made it much more complex to deal with. And so you could have made it quite complex that way. But basically, it's a fairly simple problem. Where do you think, there's something interesting about it though, where do you think people might have gone wrong? If this is a hypothetical problem you're giving to any programmer, even an experienced programmer, where's the sort of danger areas? Because we're engineers, when we set out to do something, what we should do first is work out where are the danger areas, what are the potential hazards here, and then we should address those in our approach. So yeah, 1.
Assuming that the pattern for the program was the same for the whole.
Okay, so you could have just got the Viking number system wrong. You could have done insufficient testing, yes, because it's an unfamiliar system. You could have been fooled because it's similar to a familiar system, almost the most diabolical of all systems, something that's unfamiliar but similar to something familiar but not exactly the same. Oh, that's just asking for troubles. It's like having a car which is exactly like a normal car, except instead of a brake, it's an eject pedal. But all other controls are exactly the same. That's not an advantage, that's a disadvantage. Okay, yeah. So we have to so how do we deal with that problem? The problem of maybe we get the Viking number system wrong. We do lots of tests, we communicate with each other, and hopefully everyone was on the forum communicating. There was one nasty little trick, and how long did it take people to find the nasty little trick? What is the nasty little trick? It exists in English too. It's the placement of the final and, that if you say, in English, how do you, I'll turn the lights on. In English, how do you pronounce this number in English? 1 million. How do you pronounce this number in English? 1,000,001. How do you pronounce this number in English? 1,001,000. Bizarrely enough, a 1 in this unit is treated differently to a 1 in this unit. If there's a 1 in this unit, you say the word and before it. There's a 1 here, you don't say the word and before it. It's the same in English. If you test yourself in English, I guess it comes from the old days when we only used to count up to 100, and we always, any numbers over 100, we'd always and that number on. We don't do that for bigger numbers. So interestingly enough, I experimented with friends, and I could get some people to include the and in the next grouping. So I sort of almost had this theory that it happens every second grouping. But anyway, I certainly know it for the first 2 groupings. That's how it happens in everyday English. Yes, question? No question, just waving. Hi. Okay, so that was the one nasty little trick. So you might have missed that. If you did, you'll lose a few marks. Way of solving that problem is communicating with each other and doing rigorous testing, doing lots of testing. Testing, of course, unless you test every single case, is not enough. Testing is never enough. But just because it's not enough doesn't mean we give up on it. Yeah, we do as much testing as we can. All right, thing 2 that might have gone wrong.
So just another question.
Oh, another question? Yep.
You keep saying that if something goes wrong, we'll lose a few marks. But isn't the whole thing worth 10 marks?
If something goes wrong, you'll lose a few marks and the whole thing's worth 10 marks. Yep.
So if we do something like 1,000,001, we'll lose, say, 2 marks and get 8 out of 10.
Oh, no, the marking scale won't be like that. Wait till you see the marking scale rather than trying to guess it. You'll be happy. The marking scale's fine. Okay. Yeah. I don't want to go into the details of that now. We could talk about it now. We could spend the whole lecture on it. But you know, I'd rather spend the lecture talking about programming, so wait till you see that there is a problem with the marking scale, then ask me about it rather than trying to like anticipate them. And if I'm causing tension talking about marks, I will not mention the word mark again in this course. This lecture. Yes, marks. Oh, sorry. What?
Just with the, it's not the counting system, but rather the way you go about figuring out where things go within. So if it was 21
yes.
to 2, okay, ein, you'd have to be able to call different functions within that?
Yes, the way of, I mean...
It's a syntax, I guess.
There is a difficulty in that you call the functions, you just have to get the function calling right. Is that what you mean?
But also, like, I did ifs where I did subtraction rather than modulo at the beginning. And so the subtraction would screw up how you called the function.
Oh yeah, but can I still fold that into the basic complexity of the problem? So he was just saying there's different ways of calling the functions and working out if you've got 100 left or not, and you could do it with subtractions or with mods, and there's various ways of doing that, and you have to do things slightly differently depending which path you do, and that's part of the complexity of the problem. Yeah, and it's not a trivial complexity in the problem, but let's just roll all that up into that and say that's the complexity of the problem. But interestingly enough, I think the bigger problems lie outside the complexity of the problem. Yes?
Problems with white space.
Problems with white space?
When to print the spaces.
White space problem could have been a problem. Yep. You won't lose many loops for white space problems. Yes?
I think the testing program changed a couple of times.
Yes. Oh, Richard's litany of sadness. The testing program did change at one stage. We should never change anything once it's live. And that's something you'll soon learn once you're a programmer. If something needs to change, put out an additional thing or do something different rather than changing something that everyone's assuming will behave in a certain way. Yeah, let's put that down in the incredible annoyance thing. So the problem is already incredibly annoying, especially if it's not working. Any extra annoyance it pushes you beyond belief in being annoyed. So dealing with annoyance, yes, absolutely. But there's something about this particular problem. Yeah.
Not like deciding exactly how you're going to tackle the problem before starting your code.
Oh yeah, look, that's a good one. I imagine that's a common one. You could decide to start writing the code before you'd worked out how you're going to solve the problem. That's the experienced programmer's constant dilemma. We rush into coding straight away. Really, we should sit on our hands, then write it out on paper and plan it on paper at least. Probably not using flowcharts, using pseudocode or something like that. Yeah. Yes?
Yeah, there was a problem in that if you tried to get the program working for numbers, say, under 100, the difference went after, well, 100 out, or
yes.
100. Was a bit of a concern because if you coded your program at first following the directions like making it work only up to that certain range,
yes.
Then when you moved up beyond that, you'd have a problem because you wouldn't know what you were doing.
Let's put methodology questions to the side. I mean, like we're already hearing it, some people find like one methodology and some people like another, and no methodology is perfect. There was a methodology question. Should we approach this as top-down or should we approach this as an ever-increasing size problem? And my suggestion is, for all problems, approach them as an ever-increasing size problem, and for any given problem you're working on, solve it in a top-down fashion. That's my normal approach. But yes, you're in trouble if the small thing you get working, and then when you increase it and make it a slightly larger problem, the solution needs to change in some fundamental way. There's a special name for that. Does anyone know what that's called? Annoying. It's called refactoring, when you have to change your code in that way. When you've got it working for a certain size, and then you make it a bit bigger, and suddenly everything's have to change, you say, oh, I'm refactoring my code. If you're a brave person, and at the end of this course, hopefully you will be, the refactoring won't hurt you so much. Refactoring can be okay if we get the testing right. But no, we haven't hit the thing, and maybe I'm coming from a different angle to you guys, so rather than just guessing, let me just say what it is. Oh, you had one? Yeah? Hard coding special cases. Let's put that down, wrap that up in the complexity of the general complexity of the problem. There were a lot of special cases. It was tricky to deal with those. What I'm hunting for, and oh, hang on. Yes, what did you want to say? Oh, sir, was it that? Oh, my equipment's falling to pieces. What a smart student that person was. I'll repeat what they said for anyone else who didn't hear it. They said, the danger with this program is because we're dealing with very unfamiliar output, we really have no intuition as to whether our program's doing the right thing or not. And once you get beyond 1,000 or 100 or something like that, and you're looking at your output, you have no clue whether it's right or not. You probably have to sit down and scratch your head and start doing some calculations and thinking to check it. In all problems where there's a complexity in the problem and we ourselves cannot see straight away when we've made a mistake, we are asking for trouble. The testing was going partway towards solving that, but if you wanted me to summarize this problem, the hardest thing about this problem was it was very hard to get an intuition for when you were right and when you were wrong. In fact, that's why we had ask beyond there. Does everyone agree with that? Up to 1,000, maybe you could work it out yourself. If I give you a random number, what's that in Viking? Oh, well, actually, that's not so hard. What's that in Viking? That's still not too hard, is it? And ampersand in front. Ha ha ha. So that. Now, once the numbers get big and your basic conversion to English, which works quite nicely for the first 1,000, starts to break down because of that annoying 12 factor that creeped in at large numbers. Wow, what's going on? So you've got a problem where if there's a mistake, you can't really see what the mistake is. That, for me, was the killer about this assignment, and that controlled my entire solution to the assignment. I thought, I have to deal with this problem that if I get it wrong, I won't know I'm getting it wrong. You guys could ask beyond. I couldn't ask beyond. I was beyond. I had no one to ask. In the real world, when you're writing programs, you are beyond. It's often a little logo that people put on T-shirts. When you graduate, we give you all a T-shirt saying, I am now beyond. And now you know what it means. So it means you can't ask someone. You don't have a magic oracle to consult with about the answers. There's no way of knowing if you're right or not. You've got to work that out yourself. How can you work it out on a problem where your intuition won't even tell you if you're right or not? Yes?
I would have found it easier if I told you the special cases and you were programmed instead of...
Yes. It would have been much easier if I told you all the special cases and you'd done it. Yeah. But a real world problem is never like that. If someone said to you, welcome to Iceland, or however they speak, we'll lip sync this later on, and we would like you to write a program for our bank check drawing program that, given a number, prints it out in Icelandic. Probably no one in Iceland actually knows how to convert numbers into words. They all do it, but it's probably not written down. And I reckon if you Googled round, you probably still wouldn't find this weird thing happening with the one if you looked at round. Yeah. You might, but you probably wouldn't. So you cannot rely that there's some oracle who's always going to tell you what the right answer is. So how can we work out what the right answer is? I thought I'd just show you my part of the solution that I wrote. And I will release the whole solution and put it up for everyone to see. But I just wanted to show you this one little part. Oh, I'm getting, you're not getting anything. Oh, no. So this is, I was going to show you my solution to assignment 1 and my solution to assignment 2. I just have to describe assignment 2. All right, I'm going to do something drastic here. Did everyone, very, very quickly, did you see there was a bug on the screen? That was the problem. And Macs have a special little debug button, and you just push it. You can only use it once. I'm going to have to get a new Mac now. And it just finds the bug that's bothering you at that instant and gets rid of it. So that was good. Just a one-shot thing. Windows has an opposite feature. And you can use it as often as you want. It's weird. Have you noticed whenever I say something disrespectful about Windows, they paid for my education. Yeah, that was cool. Okay. Shh. So here's my bit of code. Can you see? Oh, I got it. Just bang, clash, clunk. And let's just, where am I looking for? Xcode. And we go File. Open a recent project, Beyond. Okay, here's my Beyond. Shh. Let me make it big enough so we can all see. And let me show you the interesting thing that I did. This controlled my whole solution. I thought, I'm never going to know if this works or not. But Viking is very similar to English. So I wrote it so it would work for both Viking and for English. And I debugged it first of all on the English version. Does that make sense? And whenever I had a problem and I couldn't get my Viking version to work, I'd flip back to English. How's the difference between English and Viking? It's now an English version. It's now a Viking version. Does that make sense? It was all in my hash include. So the logic remained the same. It was just magic. All my magic numbers that make English different to Viking, because that's the only difference, magic numbers are defined in this one file, and it sticks in the English ones or it sticks in the Viking ones. So let's run it as, first of all, a Viking, first of all. And that was a real test in this assignment, I guess. If you hadn't programmed, if you've already a current programmer, I wanted to see how you deal with this problem. I'm excited. I haven't yet seen what people submitted, and hopefully some people did also submit English as well. Let's run it. It's running already. It just wants some numbers. What was that number we couldn't say? 7, 1. Hang on, I can't. What? And are you sure it's running? I'm going to stop. Go. 7. That's a debugger console. I think that's what I want, isn't it? Console. Normal console. Oh no, what's happening here? Did I compile it? I'm just moving around like loony. I didn't what? You think run console will do? Let's give it a go. It's the same. Yeah, I wish I'd saved that debug button. I used it too soon. All right, well, let's just look at my code anyway. Let's just believe it works. Okay, look, basically, here's the code here. Blah, 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 blah. And here's the Viking constants. Here are the, these are the Viking constants. That's all it's defined. So the first 20 atoms up to 19, the number of atoms, special case for 20, special case for saying 10, special case for saying 100, special case for saying 1,000, the way of saying a million. What you say after hundreds is you say ok, and what you say after tens is you say ok. I treat those differently because it turns out to be differently in Viking and English. The maximum input you can take, well, I just put a big number in, it's bigger than what you had to. The minimum input you can get, the number of digits in the system, the base of the system, and then the definitions of all the units of the system. So English, of course, is exactly the same, except it says 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to 19. The maximum atoms is still 19. 20 is said in that way. The way of saying tens is to say T at the end of the word. No, I don't have to get it exactly correct for English. I just have to get it so I can check it. Okay, so T is enough for me to check it. So when it's going to, if I type in 53 and it says 5T3, I can see everything's under control. But if it says 6T3, then I go, oh, okay, there's a mistake. So this isn't exactly perfect English. Yeah, I could have adjusted the code to make it perfect English, but that would have been adding extra features to the code that weren't needed for Viking. I was too lazy to do that. And I don't want to over-engineer my Viking solution, but this is how you say 100,000 million. And after tens, I put a dash just to make it clear what was going on. And again, everything was exactly the same except the number of digits. There we go. And I could have done this by multiplying thousands. In fact, I should have. Bad me for not doing that. These should have been defined in terms of the others. Okay, so this fully defines English. The other one fully defines Vikings. By hash including one or the other, you get it speaking out in English or in Viking, and that let me test my code. For me, that was the interesting engineering aspect of this assignment. Now, depending where you were on the programming spectrum, the interesting part of this assignment was working out how the heck to even call a function, how to get ifs to do something. Or, if you're a bit more advanced, just working out how to properly test something and how to actually extract the Viking number system properly. Or, if you could already program and were really good, how the heck did you know your program was correct? They are, I think, the three different problems that were hiding in this one assignment. Okay, let's move on from that now, and I want to go to talking about loops. And let's generate some sample loop code. I don't think I'm going to do it on my computer because I'm not confident that I'm going to get code if I put it in Xcode. So let's jump to this wonderful computer here. Oh, I did want to see if you can see what this is about. Okay, everyone watch this. This is your break. It's like a break in the middle of a lecture. It's like a break when we weren't expecting a break. Okay, is everyone ready? This is so awesomely good. Yes, it's very, very funny. I'm just going to make the volume loud so you can hear it. It's Magatu. Do people know Magatu? Yes. He's known as the adversary. This is what the adversary sometimes looks like. Here we go. Oh. Oh.
Yes.
Shh.
What Maury said I was willing to do for you. So let's get back to the reason that we're really here. Without much further ado, I'll give you the Dared Zoolander Center for Kids Who Can't Read Good. What is this? A center for ants! How can we be expected to teach children to learn how to read if they can't even fit inside a crate? I don't want to hear your excuses. The center has to be at least 3 times bigger. He's absolutely right.
Okay. What mistake did Zoolander make? He thought the model was the real thing. What was the model? It was a representation of the real thing. It was a pointer to the real thing. It would be terrible to think the pointer to the thing is the thing. But we do it all the time. Even famous models do it. Okay. So, there you go. Who's seen that film? Yeah. It's not very funny, is it? It's very good. Okay, now, we're going to, without much further ado, we're going to open... We're going to look at some loops. You guys mutter amongst yourself as I log in.
Why do you keep changing his password?
Okay, is everyone cool? Who's writing the wiki notes today? Wave your hands if you are. Is it like 16 of you? Cool, well done guys. Good organisation. Tim, I didn't say by the way, Tim's sitting here. did you come in part way? I don't think I saw you at the beginning. I just sort of announced to everyone that I'm a bit worried at the speed at which some people are having troubles in the labs. So I'm not going to introduce loops. I'm introducing loops today. I mean, we're working on loops. I'm not going to bring arrays in today, and you can introduce arrays next week. Okay. So we're sort of like shifting back almost a week. Yep. And I'll release the assignment after I come back on that Monday. Yep. Okay. That's just a private conversation between me and Tim, so I hope no one was listening. Can you all just...
It's going to be a surprise.
Okay. Were there any questions? Did I see a hand waving just then? No, I didn't. By the way, did you notice the lecture theatre was less hot and oppressive than normal when you came in today? It was still hot and oppressive and smelly. It was worse. No, I thought it was... Oh, was it worse? Because I did a clever thing. I rushed in... Last week I rushed in here in the hour before the lecture and started the air conditioning, so it would have been running for an hour by the time we came in. But last week it was still smelly. So this time I rushed in 2 hours early, snuck in between two lectures, and started the air conditioner to the surprise of the lecturer who was lecturing at the time. And I thought it would be much cooler, but it didn't work again.
It's really all right.
It's all right. You're down the bottom. You're underneath the cloud layer. Okay, anyway, all right. So is it worth doing again? Yes, wave your hands if you think I should do that again. Or it's just funny to make me do that again? Yes. Okay. All right, now we're going to have a loop. And yesterday we wrote a loop to print out the letter E a couple of times. Today I want to write a program that reads in text and counts the number of times the letter E occurs in text. Because as I said before, if we had a Caesar cipher, which is a cipher that shifts all the letters on by 1, or if we had any basic substitution cipher, which takes any letter and replaces it with a constant different letter, we'd crack it by frequency analysis of the letters. We'd look what's the most common letter, and that letter is E. So let's write some code to calculate the most common letter in a piece of text. So we're going to have like some sort of counter that counts the number of E's, and we should probably count also how many letters, so we can get a percentage, because there'll be lots of stuff in the input that aren't letters, like there'll be end-of-line characters that are invisible, and spaces, we're probably not counting them, because they're of course much more common than E, and commas and apostrophes and all that sort of crap. Let's throw away everything except the letters. So we should have two counts, I reckon. One counting the number of E's we've seen, one counting the number of letters we've seen, and at the end of running the program we should print out the percentage of E's, and that'll tell us. Okay, does that all make sense? Yeah. Okay, now, what sort of numbers am I going to need to store the number of E's and the number of letters? I could have it as ints, and that would be absolutely fine. What's the ultimate output going to be? A float, which we're going to pronounce double from now on. Though I'm going to call them floats, because I'm old, but you guys are young. The hip way of saying float is double. Okay. Because floats are too small to be used. I could just make it all double from the beginning. I don't know, what do you think? Pros, everything's going to work just fine. It lets me count absurdly big. Cons, I'm really thinking it's a count. I'm not expecting to be able to see half an E. It might be confusing to someone else if they see it's a floating point, a double number. Conclusion, type 10. I like the way you're thinking. But let's keep it as basic types. I'm going to say int because you're right. Int makes the most sense because it really is an int. And I'm just going to have to remember to do that conversion, because if I do a division at the end, if I say the number of E's divided by the total number of letters, what am I going to get? 0. Yeah. Because it's going to be smaller than it's going to round down to 0. Yeah.
I think you should make it an unsigned int.
An unsigned int, so I can go to many E's.
Yeah. Well, because it's never going to be negative.
Oh, yeah. I could have unsigned int because I can't have a negative number of E's. Yep, that's fine. I don't know why I wouldn't. I guess it's just, what would you do, Tim? Ints is like standard. Yeah. I think you'd need a reason to deviate from the standard. That's a mild reason, but I wouldn't think that would be a strong enough reason. You would just use an int?
Because ints go pretty big.
Ints can be big. Ints are normal. To do something unusual, if it was unsigned, I'd be thinking, what? Why did they do that? And I'd be looking for a really deep reason.
Unsigned gives the program greater scope then.
Yeah, look, there's nothing wrong with unsigned. If you did it, maybe put a comment in, because the programmers are going to be reading that and go, wow!
It also means it's impossible to represent
states
that don't make sense, like having a
yes.
number of E's.
Yes, you can't represent states that don't make sense, but if you got one of those states that didn't make sense, it would just represent it as a state that made sense, but it would still be an error just disguised as the real thing.
Use a real language.
So look, all of these thoughts are good, and it's good to think these thoughts, and you can come to whatever conclusion you like. My conclusion is, whenever possible, I'll just do the standard thing, and then a programmer reading it is just all relaxed. And I only want them to get excited and alerted when I'm doing something unusual that I think needs their attention. So let's go int What am I going to call the number of e's? Well, number of, it's an int, so it's going to be a number. What about just like e count or something like that? E count, no, saying int number of e's is Hungarian notation. Or number of e's int. Or number of e's unsigned int, or, yeah. So we're going to say e count equals 0. And number of e's isn't bad, by the way. And we're going to say int, and this will be like letter count, thank you. Might as well initialize it all to 0. And then I'm going to have to go into a loop because I don't know how much text I'm going to get. So my plan is in the loop I'm just going to read in a bit, read in a bit, read in a bit, read in a bit until I see what? End of file. So I'm going to do something like while, oh, I guess I'm going to have to read in a character, aren't I? Int, it's a plain text is what we call no, it's a ciphertext. No, it's the ciphertext. So, but it's not a whole text, it's just a character. So let's call it the cipher char. The cipher character equals, oh, we won't initialize it just yet. While cipher char is not equal to end of file. Oh, it's not initialized. Oh, gee, how did I make that mistake? Well, how could I initialize it? I guess I could just initialize it to a piece of rubbish like 0. Is that a good way of initializing it?
Yes.
Why yes? Because I'm thinking no.
Because otherwise you're going to have to put the get char at the beginning of the loop, and then you will be dealing with an EOF character where you're expecting a letter.
Yes. If I don't do that there, I am going to have a get char now. But I reckon it's not good for the reason that I think someone said. I mean, so it's not a bad thing, but I think there's a better answer. Yep? EOF could by random chance be 0 maybe, and that's the general thing. Can I paraphrase that? Everything should have meaning. Is the cipher char 0? No, that's like a control code or something. That's something I'm putting in to control the flow of the program. This is a piece of data, and I've said that this is the cipher character I'm reading. I should never put in anything in here unless it's a cipher character. That's what the name says. It's not called cipher character, but the first time through has a different meaning, because that name would be too long. So we like everything just having one meaning. So if it's a cipher char, it's a cipher char. If you want to control things with flags, have variables called flags. Yes?
Should we just initialize it to not EOF?
We could initialize it to not EOF. EOF's not a logical thing. EOF is a code. Well, here's what we could do. You could do something like, I'm not going to want to do this, but we could do, I'm going to say this is stupid, okay? I'm not stupid, I'm not going to support this. So if you're watching it on the movies, don't stop it now, okay? Because you missed the bit where we go, whoosh, but it was Old Man Smithers all along. Hash defined not EOF is 25. Something crazy like that. And then, oh, thank you, semicolon, that's bad. And then, but now what's the problem? Someone said the problem in this case would be, what if EOF happened to be 25? So what do I need to do? I'm assuming EOF's not 25, so I should assert not EOF not equal to EOF. Okay, now it's a bit safer, but it's still got this problem. In addition to now we're just doing crazy complicated stuff, it's still got this problem that I'm storing in it a flag value, and it's a cipher char. I only want to store cipher chars in there. I'll let someone else have a go. Yep, because I know it. Yep.
Why not have a get char before the...
Oh, I like that. I like that idea. I like that idea. And this annoying extra get char is a reason a lot of people like using fors, because they can just not type it. But let's comment that out. Let's comment that out. And let's say equals get char. Let's just read the first character.
So that was the initial suggestion.
That's what I said.
Yeah, but I ignored it. I ignored it. I'm sort of thinking of a funny reason why I ignored it, but it's not worth going down that diversion. It was going to be like it was the first thing you said, and that was control information rather than the actual answer to the question. You know, I could have made a joke somehow with a bit of effort, but I'm not going to because it's crap. Thank you. It's just not worth effort on crap jokes. Okay, so we go. No more calling out. Let me make my errors my own delightful way and be surprised innocently every time they occur. So we've got int cipherchar getchar means cipherchar now contains the first character that we're reading in. If it's not the end of file, then what do we need to work out? If, so I can't even remember how to spell cipher, C-Y-P-H-E-R char equals E. Does E go inside double quotes or single quotes if it's a character? Would it be good or bad if I put an equal sign here? Bad. Thank you. Now what am I going to have to do? Just decount plus plus? Now letter count. Well, do I want to make use of the fact that I know E is a letter? I guess I could make use of that fact. So if I'm going to do that, I could say if, let me just be lazy. Oh, and I'm missing a. Now I can say if is alpha cipherchar, if it's an alphabetic character, oh, that's worth knowing, then I'm going to increase the letter count by 1. And then I'm going to check further to see if it's an E, and if it's an E, I'm going to increase the E count by 1. Now what's this is alpha? I'm trying to remember, I might not have even got the function name right. It's a specially defined function. C's got a whole lot of specially defined functions that we don't have to write ourselves, if only we know they exist. There's a whole lot of useful ones for dealing with characters in a file called ctype.h. They're declared in ctype.h. So go and look at ctype.h on your system or Google ctype.h and you'll see a whole range of really neat functions that you're now allowed to use. So I need to include it to get this power in my program. Okay, let's just get rid of this confusing thing there. That's just going to freak people out. How's that looking? It's looking pretty good, except not printing anything out. Let's print something else out at the end. Oh no, have I fallen for one of the classic blunders? Remember, there are 3 loop classic blunders. I haven't done the update step. I've done the initialize bit, which is reading the first character. I've done the processing work. I've done the test to see if I should stay in the loop or not. But I haven't done the thing that you do at the end of the loop, which is the update. Now in this case, and actually it often happens like this, the update is the same as the initialize. So why don't I just steal it, in fact? That's here, and we don't need that int, or that level of indenting. Does that make sense? So read 1 character in. Let's go up. Oh, I can't scroll that way. Let's scroll this way. Right. Read the first character in. So long as the character most recently read in is not the end of file, which is defined in stdio.h, so that's all right, then check to see if it's an alphabetic character. If it is, increase the letter count. And further, if it is, check to see if it's the letter E. And if it is, I guess I'm not doing capital E, so we just not worry about that at the moment. Then increase E count by 1. Suppose I'm just looking for lowercase e. And then at the end of doing all my updates, let's read another character in and test it again. Go back to the start of the loop. Does anyone have questions about that code? Yes?
What about capital E's?
Yeah, capital E's are a problem. Is alpha is going to return a true or a false. In C, how do we encode true or false? Remember, C loves ints. So 1 and 0. Well, actually, strictly speaking, 0 and not 0. So anything that's not 0 is considered to be true, and anything that is 0 is considered to be false. So is alpha is a function that returns a not 0 if the thing you've just put in is an alphabetic character, and a 0 if it isn't. Oh. Are you saying, do we need to get the output of that and compare it with 1, say? No. The comparison operation, double equals, will return a 1 or a 0. In this case, it would return a 1 if his alpha was 1, and it would return a 0 if his alpha is 0, so you might as well just get his alpha. Also, the way I've written it here isn't safe, because what if alpha char didn't return 1 to mean true? What should I have said? I should have said not equal to 0. But it's just as easy to say, dumb. And it reads and makes more sense to do it that way too. Okay, so let's save this. That was a really good question, by the way.
You've lost your brace on the next line.
I've lost, oh, thank you. I don't return anything. Did I say I was going to return something? I did promise I was going to return an int, and I didn't. Thank you very much. Return. Let's see if it explodes. Let's compile it. I'm not printing anything out, but I just want to run it. Let's go /loop. This is going to run it. Now it's going to read something in. It's not reading anything in until I hit enter, and then it's going to read all those things one at a time. At the moment, these characters are being kept by the operating system. They haven't been passed to the program. As soon as I hit enter, they're going to be passed to the program. They've been passed to the program. It's updated the count. I could do some more typing. And then I'm going to finish, and I finish with Control D is the end of file character, and it's done. It didn't print out the results, though. So let's tell it to print out the results. That return 45 was a bit naughty, shouldn't it? Yeah, that's right. Printf percent proportion of ease is percent. Oh, now someone help me. I can say D here, can't I? Someone corrected me on this on the other day. I don't have to say anything else, just percent D. Is that right? Percent D? Well, let's try it. Well, I thought it was FL, but someone said it was, I could do D. So I'm going to try, because I think that's interesting to know. Let's find out. We'll find out. We can find out. Oh, D is decimal. Yeah, so that's not going to work, is it? It's integer. So someone think capital L. Yeah, that looks better. A long float. And I don't think I need the F. Is that correct? I don't think I need the F. Let's find out. Now, if I said here, E view over let's indent it so it all looks beautiful. What do you think of that? What's it going to return? 0. That's no good. I need to turn it into a float. How the heck am I going to turn it into a float? What if I do this? Oh, double, I mean. What if I did that? Would that work? No, that's not going to work. Oh, well, I'm not sure if that'll work. Here's two worlds in which it might or might not work. If I remembered precedence operator, I'd know better. If it evaluates this first, because two things are happening in this line, a division and then a typecast. And I can't remember which one C will do first. Because I never remember things like that. And I don't think it's important to. Of course, because I never remember things like that. Okay. If it does this first, it'll be 0. And then it'll convert it to a double 0, 0.0. That's useless. What we want is to convert it, but if it did this first and converted the count to a double, and then divided a double by an int, it'll do double division. Does that make sense? So what I really wanted to do, this is just being over the top obsessive, is I wanted to do this. Double E count divided by, this is way too, I don't need this many typecasts. As soon as there's one double in the picture, C is going to be happy. But now I've converted them both to doubles first, and then I do the division. I have no idea if the brackets are going to match there. Do they look like they're matching? Whew. It's an LF? Thank you very much. Let's try. I'm incorrect. Well, look, I'm incorrect so often it makes me happy. I don't mind. I'm relaxed. Let's just try it and see. Long argument, but it has a type. Oh, LF is long double. Let's just try a capital L. A long double is even longer than a double. Too many arguments for the format. Oh, what have I? It's lowercase l? No. I think I've got my brackets wrong. Let's count them. Open, the whole expression starts here. Open, close. Close the whole expression. Oh, there you go. There's a problem straight away. There's one missing at the beginning. There's too many at the end? Well, let's have a look. This one matches with this one. That's good. This one matches with this one. That's good. And then the whole thing is surrounded by those outer two that I skipped. So it's looking better. Yeah, I could have made a mistake. I know. I'm going to try it anyway. Control reaches end of non-void function. What did I do? Printf itself needs a bracket. Thank you. Forgot about that. Let's put that down here so we know. That is. What did you think of our clever idea of using ints? Has it given us happiness? It's given us disgusting error, disgusting code. Too many arguments for format. Oh. Now at this point, Richard goes, I'm thinking double. Double, because life's too short. You think I've got an extra bracket? No, this one matches this one. It's %LF? Oh, you think it's lowercase LF? Okay, cool. Let's give it a go. I wish you guys were with me all the time when I was programming. Wouldn't that be cool? If whenever you're programming this, it's like chorus of chants. No, no, no. That'd be so cool. This is super extreme programming. That's right, Theo's right. Extreme programming is when you are pair programming with someone else and they're watching you over the shoulder the whole time you're typing, and you take turns of being the typist. It's very threatening at first, but you soon come to trust each other, and it's really cool because as soon as you make a mistake, the other person fixes it up, and all your minor differences just disappear. You think, it's just not worth arguing about this or that, so you start sort of getting all the rough edges knocked off you, and you come up with this very nice sort of average way of programming. It's very nice. Okay, let's run the loop. Let's type in all our text. I did do a lot of typing there, it's just not picking it up. And I'm going to go Control D. 0, we got that rounding error. Oh no, that was a bad test case. Okay, so our E counter appears to be working. Is everyone cool with that? Question? What if the number of letters is 0? Let's find out. Is it possible for the number of letters to be 0? Yes, it is. If the first character read isn't an alphabetic letter.
Or if it's an EOS.
Yeah, which is not an alphabetic letter. So in any case where the first character read is not an alphabetic letter, then, or there's a string of there's no alphabetic, then it's going to crash. So what do we need to do here? We need to take one of two paths. Either we need to go back and work out what the person that asked us to write this function wanted. Did they say, you can be sure there's at least one letter? If they said that, what do we put in here? Assert. If they didn't say that, what do we put in here?
Error handling.
If error handling. Let's just say I said that. Okay, so I'm the person that gave me that job. And I said, oh, and you'll never get an empty thing. Thank you very much. Assert letter count is greater than 0. Now, you know, if you're a hackery person, you could go, oh, what about asserting not error count? That would do the same thing, remember? Because if the error count is 0, that's also, if we pretend it's not an integer, we pretend it's a Boolean, that's a false. So not false is true. So I could just say not error count here. But then I'm confusing something that should be a number with something that should be Boolean. We should never do that. Make your Booleans Booleans. Make your numbers numbers. Boolean means true or false. This normally is a number. Sometimes okay, so I'm not going to do that. Let's run it. Oh, assert needs to be defined. Assert.h. And let's go compile it, run it, type in some stuff. The quick brown fox jumped over the lazy dog. He said, that hurt. Okay. Now, so far, slightly interesting. But Unix, the environment we're operating in, and DOS as well, if you're using Windows, whatever the Windows command line thing's called now, DOS or command, I think you have to type CMD. If you go run in Windows, oh, in fact, we've got Windows here. This will probably be security crippled, I probably won't have it. But normally in Windows, there's something here that says run. If you clicked on that button, and said CMD. No, I'm not even going to try. No, there's a way of playing with Windows. I'm not going to. And now it's not. Go away. This pop-up, how do I make it go away? I have to click on something. Start again. Oh, man! I got to reinstall Windows probably to get rid of that. Oh, shut down the whole computer. I knew it wouldn't do that. That was probably a bit dangerous though, wasn't it? Okay. So if you go run on that thing there that popped up on your Windows machine and type CMD, a little box will pop up that looks a bit like an X term. And you can do the same thing that I'm about to do now, which is in Unix, instead of typing input in from the keyboard, you can say, I'll take all the input from this file. Instead of getting it to print all the output on the screen, you can say, hey, print all the output in a file for me. So I could do this. Wrong thing. I could say, loop. This means the arrow, the greater than symbol does it in both DOS and Unix. You see it's pointing one way. It's like saying into the function. So this is what I'm going to send into the function. Instead of the keyboard, take all the input from a file. What file do I have in this directory? Loop.c. Let's count the number of E's in loop.c. Does that make sense? 11.5%. Almost indistinguishable from that gibberish I typed before. We went to a lot of trouble when we could have just typed gibberish for this program. Okay, does everyone see that? So that's pretty cool. So you could get, and I have done this in the past when doing cryptanalysis, you can go to the online Gutenberg. Yeah, go to Gutenberg and the Project Gutenberg where they have free online texts and download as many files as you can. And I downloaded every single book I could find once. I got like gigabytes of stuff. I got Bibles and the complete works of Shakespeare and everything. Got it all down, all compressed, unzipped it on my machine, had a huge file, and I passed it through a program that stripped out punctuation and numbers and headers and footers, and I took out all the spaces between the words, and I just had this big file of letters, and it was like a gigabyte big. And then I said, count it, and it gave me the frequency distribution. Yeah, which was particularly good if you're ever trying to crack a message written by Shakespeare. Or in the Bible, because they feature in there a lot of time. You could do that, and this program would do that, and it would sugar through. It's going to take a long time to go through a billion stuff. Okay, now we're going to take, I'll ask if there's any questions, then we're going to take a break. Then everyone that's already comfortable with machine code, just go, and I'll see you next, no, Tim will see you next week. I'll see you in 2 weeks' time. Anyone that would like machine code revision, stay, and I'm going to talk about machine code and just answer questions, and we'll do examples on the board. Last thing to say before I close up is, shh. Next week I'm going off to Hong Kong. I've never been to Hong Kong before. Is there anyone here from Hong Kong that knows fantastic things I should do in Hong Kong? Yes, what should I do? Don't go to Disneyland. That was already on my list.
Do go see Victoria Peak.
Go shopping. Anyone with suggestions, write them on the forum. It's non-examinable. Yeah? Go to the gym so I can get fit. Yeah, I like the way you think. I'm escaping my problems. Okay. Shh. Get a Rolex. Why would I? Get a Versace. Get a Versace. Shh.
Take a shopping.
Anyone that has suggestions, if they're really good, post them on the forum and I'll get stuff. And if you have friends you want me to say hello to, I'm just over there just doing stuff. Now, are there any questions about this? Let me make the code larger. Are there any questions about this? Yes. What happens if I put the 0 character in? Oh, yeah, you want to see what the assert does. He'd like to see how the assert behaves. I like that sort of thinking. Let's try it and see. Loop. I'm just going to hit Control D. And it tells me the thing. Count is greater than 0, failed. And that is really nice, because not only am I getting an error, it's telling me what's going wrong. And I can look through my code and find where I asserted that. Yeah.
Why would mine be telling me core dumped at that point?
Are you using Windows?
No, I'm using Linux.
Why is it core dumping? You've got some problem with your assert. Yes, it'll core dump if you try and do a division by 0, possibly, or throw a floating some error.
What happens if you don't put the assert in if you do divide by 0?
Good question. What happens if you don't put in the assert and you do divide by 0? What am I going to say? Try it and see. Everyone should try it and see. Division by 0 is like the worst thing you can do to a computer. Try it and see on your dad's computer. Not on your own. Okay. Last question. Shh. One last question, then we're going to have a break for 10 minutes. Yes?
Why aren't we allowed to assign assign EOF to cyberchar already in the loop is going to be assigned, like get char might return EOF.
Yes.
How come it's going to be forced to use cyberchar as a flag or as a character anyway?
No, ask me that offline. Okay, good. That's a good question. Okay. Let's take like a 5-minute break or 10 minutes and just go if you don't want to know about assembly code. And if you do, move a bit closer to the front and we'll race through assembly code. All right, see you guys in 2 weeks otherwise.